Today we're going to be demonstrating how to use a spectrophotometer. In order to use a spectrophotometer for this experiment, we had to measure out approximately 0.125 grams of copper sulfate pentahydrate to create our stock solution. This measurement was determined by using a balanced chemical equation in stoichiometry as seen here. Using the stock solution, we created a set of 3 dilutions for use in the spectrophotometer. For the first dilution, we used 5 milliliters of stock solution and 10 milliliters of water. For the next dilution, we used 5 milliliters of the solution from our first dilution and 10 milliliters of water. The third and final dilution utilized 5 milliliters of solution from the second dilution and 10 milliliters of water. Using the M1V1 equals M2V2 equation, we were able to determine the approximate concentration for each dilution. Once all the dilutions have been prepared, we transferred the dilutions into cuvettes for use in the spectrophotometer. In addition to the dilutions, we prepared a cuvette that solely contained water. This was done to zero out the spectrophotometer. The spectrophotometer must be zeroed out prior to use to filter out any species within the machine that would affect the accuracy of the absorbance reading, such as background color.
So Beer-Lambert's law is a law that states that absorption and concentration are directly proportional to each other. So as one increases, the other one increases, and if one decreases, the other is also going to decrease. So if you look at the equation here, A stands for absorption. This is going to be molar absorption, molar concentration, and then this is going to be your optical path length. So that's going to be the length of how far the light goes before it's absorbed.
To zero out the spectrophotometer, first, you must wipe both the side of the water cuvette that will be facing the light source and the opposite side of the light source. This ensures that no dirt or dust will interfere with the absorbance reading. Place it into the machine, close the door, and press the 0 button until a reading near or at 0 is reached. After zeroing the machine, wipe the sides of the cuvette containing the corresponding solution and place it in the spectrophotometer and close the door. Press the read button on the computer and record the absorbance reading. Repeat this for each dilution until all 3 dilutions have been recorded. When using the spectrophotometer, it's important to measure across all wavelengths so that way we can establish a proper relationship between the absorbance and the concentration. There may be other values across other wavelengths that we may not know about, as well as finding our lambda max. Lambda max is the wavelength at which a substance has its strongest photon absorption. Essentially, it's the highest point of absorbance. Hence, we have to record across all wavelengths. After obtaining data from the spectrophotometer, we were able to determine that a light absorbance is directly proportional to concentration. As with all experiments in the lab, we must clean up our workspace prior to leaving our stations.